So I want you to answer questions 1, 2, and 3. See if you know those answers. Okay. So question 1. Are 3 diameters of a circle concurrent? True or false? Yes or no?
Yes.
Yes, that is true. Are 2 diagonals of a rectangle concurrent? So a diagonal of a rectangle goes from here to here, and there's only 2 in there. Are they concurrent? I hear yeses and I hear no's. What is the definition of concurrent lines? 3 or more lines that intersect in the same place. This is not 3 lines. So therefore the answer is no. And because it's not 3 or more lines. When they said 3 diameters of a circle, that's why those were concurrent. They all intersect at the center of that circle. Is point C at the right a point of concurrency then? Yes. It's 3 lines. Then we have a new definition. So this definition is median. The median triangle has one end of it at the vertex of one of the angles of the triangle, and the other end hits the midpoint of the opposite side. So this line right here is the median of a triangle. There are 3 medians in each triangle, one coming from each vertex. And all they have to do is show that these are equal or tell you that B is a midpoint. So as long as the median comes from the vertex and hits the opposite side's midpoint. There are 2 characteristics to each of these types of things that we're looking at. There's 4 altogether. We looked at 2 yesterday, and we're going to look at 2 today. So this is our 3rd thing. So we've already looked at angle bisectors and perpendicular bisectors. So we're going to look at medians. So we're going to write out all kinds of characteristics and things for you to study. You need to know them by Friday. So you'll have a nice little neat study guide at the end of this today. So look at 4 through 5. True or false? The median, so think of what the definition of a median is. It has 2 parts to it. It must come from the vertex of a triangle, and it must hit the opposite side's midpoint, or bisect the opposite side. So it says the median of a triangle is a segment that connects the midpoint of one side to the midpoint of an adjacent side. That would be, and I'm guilty of calling this a median only because my last textbook always called it a median. But what they're showing you is this right here. What does our textbook call that? This blue line. This is a mid-segment. So what they're describing to you is a mid-segment. So this is false, because they're describing a mid-segment. I guess I should put a little tick mark here, 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 and here. And then question 5 says the point of concurrency of the medians of a triangle is where they intersect. So the point of concurrency of the medians of a triangle is where they intersect. Do you think that's true or false? It is true. Isn't the point of concurrency where the perpendicular bisectors meet, and the point of concurrency was where the angle bisectors met? So therefore the point of concurrency of where the medians meet is also that as well. So this is true. A triangle has 1 median. I already answered that. True or false? So any triangle, so let's just draw any triangle. I'm just going to draw this one here. To draw a median, I'd have to bisect this side, so I'm going to put a midpoint here. So this would be 1 median. Could I bisect this side here and have that line come from an angle? Sure. Could I bisect this line and have that line come from another angle? this right here the point of concurrency. So aren't there 3 medians in a triangle? Not just one, there's 3. So for every one of these parts or pieces to the triangle, there's always 3. So the answer to this is false. Right there, that should be 3. Then I want you to circle the drawing that shows the median AD of triangle ABC. Did you circle the left or the right one? The left one. What's the right one showing? Angle bisector. Good question. Is it possible for a segment to be both an angle bisector and a median? So for it to be a median, what would have to happen? So if this occurred as well, then you could say that AD is both an angle bisector and a median because it meets both qualifications. An angle bisector has to come from an angle and hit an opposite side and bisect that angle, which it does. A median has to come from the vertex of a triangle and bisect the opposite side, which it does. So it is possible for both to occur. Yes. That will occur, this typically will occur in isosceles and equilateral triangles. In an equilateral triangle, your median, your angle bisector, your perpendicular bisector, and we're going to learn, what's the one I've left out? No, because it can bisect an angle and not bisect the side opposite. So for instance, on your notes yesterday, here's your angle bisector. Notice here it's not bisecting this side. It depends on your triangle. If you have more than one congruent angle in a triangle, then yes, it will bisect at least one of those sides. So typically with an isosceles triangle, the angle bisector comes from the vertex, which is in between the two legs. In an equilateral triangle, it comes from all 3 of those. Any other questions on that? Those are all good questions and observations. Okay. So we have a new theorem for medians. Why do I feel like I'm so crooked? I don't know if that's an improvement. All right, so this is the important part. The medians of a triangle are concurrent at a point, which is called the centroid. So there's a new vocab word for you. I easily have to call them all different things. There's your centroid. At a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So there's an interesting tidbit. 2/3. So each of these things create different congruent things within the triangle. Well, this one's not quite congruent. What it does is it says that this piece, from here to here, the longer piece, so this whole piece right here is your median. I know it's a median because it comes from a vertex and it's bisecting this opposite side based upon the tick marks. What they're saying is this piece right here, DC, is 2/3 of the entire length of that median. And so right here, I'd like you to write that DC, which is this longer piece, is equal to 2/3 of the entire piece from D to J. Ian, you're not going to write any notes? Might be important to you. BC, which is this piece here, you can see it's the longer piece out of the 2 pieces that are created by that point of concurrency. So EC is the longer piece. It's equal to 2/3 of the entire median, EG. So what would you say about FC? It's equal to what? 2/3 of FH, the whole length. That's going to become important when you're solving some things today. So let's find the length of the median. So as you can see here, these are all medians. They're not angle bisectors, they're not perpendicular bisectors. So this point right here is your centroid. What a great word. Centroid. And what that does is I'm just going to draw one of them. Well, we're specifically looking at ZA. So from Z to A, Is that the longer or the shorter piece of that median? Visually, longer or shorter? It's a longer piece. So I know that ZA is equal to what in comparison to the whole distance? It's 2/3. And they told me that ZA is 9. So I'm going to write on my picture 9. So then we're going to substitute in the value for ZA. So ZA is 9. 9 goes here. And it's still equal to 2/3 of Z. But now we're going to solve. We want to get ZC by itself. So here's the problem we've written. How would I solve for ZC? How do I get rid of 2/3? Multiply both sides by the reciprocal of what's happening to ZC. Try saying that 10 times once. So I'm going to multiply. Yeah. I'm going to multiply both sides by 3/2. I'm going to put the 9/1, and unfortunately nothing cross cancels, nothing simplifies. These do over here. But 3 times 9 is 27, 2 times 1 is 2. 27 is equal to ZC. I prefer that as the answer. 27/2. Or I suppose you could give me a decimal. 2 goes in there once, nothing left over. 2 goes into 7 3 times with 1 left over. What's 1/2 as a decimal? Yeah, what's 1/2 as a decimal? 25. So then, couldn't we find the measure of CA if we had to? What's the measure of CA? What's the measure of CA? Well, we know this is 9, and we know the entire distance is 13.5. How are you going to find CA? Subtract. You've got 13.5 minus 9 equals, what's 13 minus 9? 4. So would I have 4.5? Right? So they put it actually out as well. Then we come to the difference between a median and an altitude. So an altitude is our last piece. So an altitude has 2 characteristics to it as well. An altitude comes from a vertex of a triangle and it is perpendicular to the other side. Its opposite side. It must come from a vertex, it must be perpendicular to the opposite side. Now an altitude could be inside the triangle, outside the triangle, or on the triangle. Altitudes do not necessarily go, unlike all the other ones, altitudes do not necessarily always go inside the triangle. If you think about it, and we're going to draw some pictures over here in a minute. Yeah, of our altitude. So I'll show you what all that looks like. But consider the following problem. For triangle ABC, is each segment AD, EG, and CF a median in altitude or neither? So what are the characteristics of a median? From the vertex to the opposite side's midpoint. So that's the characteristic of the median. In altitude, must do what? Come from what comes from the vertex, and it is perpendicular to the opposite side. Are you eating your lunch at 7:48 in the morning? Do you have 2 lunches today? What's going to happen at lunch? You're going to be a hungry boy. Did you not have breakfast? I could not eat a turkey sandwich at 7:50 in the morning. It's good. All right, so look at number 12. And number 12 is kind of a weird question. It says, read each statement, then cross out the words that do not describe AD. AD is what? Just looking at the picture, what's AD? How do you know it's a median? What's the characteristics that you see? Comes from a vertex, and D is the opposite side's midpoint, and it touches D, right? So we want to cross out anything that doesn't describe AD itself. So read each statement, cross out what doesn't describe it. AD is a segment that extends from vertex A to side CB. Does that describe AD? Yes. Which is opposite A? Does that describe AD? Is AD opposite A? That's why it's weird. No. What is this describing? What's this part describing? It's describing CB. So that's why we're crossing it out. And then AD meets segment CB at point D. Does that describe AD? Yes. Which is the midpoint of CB, since CD is congruent to DB? Does this describe AD? Is AD the midpoint of CB? Is AD? AD is the midpoint. No, only D is the midpoint. This does not describe AD. What is that describing? Point D. AD is not perpendicular to CB. Is that describing AD? Yes, the whole thing. Yes. So we're going to keep that. So AD is a segment that extends from the vertex to CB. AD meets CB at point D. AD is not perpendicular to CB. So does that tell you that it's an altitude, a median, or neither? It's a median. The altitude would be perpendicular, right? Did I just circle something that should have? I don't know why. Wait a second. If we just say, okay, AD is a median.
Oh, it was so kind of cross out on the
Oh, do you think that's what that is? Okay, so we're going to cross that out, cross that out. All right, so then part 14, read the statement and circle the correct description. So I want you to do that for EG and for CF. CF's on the, you have to flip it for CF. So you go ahead and do those on your own. So determine if they're median, altitude, or neither. So for 14, it says segment EG, this segment right here, does not extend from a vertex. So if it doesn't extend from a vertex, could it be a median? Nope. Could it be an altitude? Nope. So therefore it must be neither. What is this? What do we guess this could be? Because we don't have quite all the information, but what do we guess EG is? A mid-segment. We don't have enough information over here to determine that, but it appears to be a mid-segment. So then 15 says segment CF is a segment that extends from vertex C to side AB, which is opposite C. It also says that CF is perpendicular to AB. So we have a segment that extends from a vertex and is perpendicular to the opposite side. So CF is from here to here. Is that a median, an altitude, or neither? Median, altitude, or neither? Altitude. It matches the true characteristics of an altitude. Okay, so then let's look at the concurrency theorems of altitudes. So you get yet another vocab. So there's 4 different words that describes the points of concurrency of each of the 4 things that we have looked at. The perpendicular bisector, the angle bisector, the median, and the altitude. All have points of concurrency, and all points of concurrency are different vocab words. Yippee skippy. Are you excited about that? I know I am. So the point of concurrency is the orthocenter of the triangle. The orthocenter of the triangle can be inside, on, or outside the triangle. Which other one is that like? which is created from what? The perpendicular bisector. Yep. So it's the same as your circumcenter. So similar, you might want to put here, similar to circumcenters of perpendicular bisectors of a triangle. So now we're going to draw an example of each of the different triangles. So let's draw an acute triangle. You want all three angles acute. So an altitude must be perpendicular. So I'm going to draw from each vertex a perpendicular line, dashed. So there's the altitude from that one. Altitude is also known as the height of a triangle. So as I turn my paper, here's an easy way to, let me go find I'll use this little piece of paper. You want to be able to extend a line out so that it's perpendicular to the side that we're looking at. So I want, from here, this is not perpendicular. So as I extend out my ruler, I'm going to run the bottom of my ruler along this line here until it meets, well, maybe I did inadvertently turn it right angle. Well, that was a big good. Let me redraw my triangle. I don't want to right angle. I definitely don't want to right angle. So, drawing the lines back in, and you'll see why I don't want it in there, because I want to prove something to you. Because if I draw a right triangle, is that acute? Is a right triangle acute? No. Alright, so let's draw here, here, and here. Alright, so there's an acute. So then my altitude from the top vertex is quite easy because it's just vertical, right? Perpendicular, hard to see. Right there. So there's my first altitude. Then to get this altitude, I'm going to turn my paper and I'm going to run my ruler across the side opposite of the angle I'm trying to draw the altitude from until I hit that angle. It's handy to be a little ambidextrous. So here we go. So there's that altitude. And then I want to turn my paper again. And I'm going to run my ruler again along the bottom here. I want them to be flush and to line up until I come to my angle. Met with a little resistance. Alright, and so then I draw in my altitude from that side. And where do they meet? Inside, outside, or on the circle, or the triangle? Don't they meet on the inside? So they meet on the inside. For an acute triangle. Then we're going to draw an obtuse triangle. So you want one obtuse angle. And draw it exaggerated. So when you draw your altitude to this opposite side, is there any way for me to draw an altitude from this angle perpendicular to that side? Not unless I do what? I have to extend out. Sometimes I have to extend out the side of my triangle because the altitude can be outside your triangle. So now as I run my ruler flush with the bottom there, now I can hit my angle right here. So that altitude is outside the triangle. It's the only part of a triangle that can be outside of it in altitude. All the other ones come from inside. And so it does come from the vertex, and it does hit the opposite side perpendicularly. Your new word. But I had to extend the side for that. So then I'm going to turn this to get my altitude from this one. It's easier for me if I'm looking at the vertex from a north angle. And so I'm going to run this across here. Which, trust me, some of you are not going to be able to do this if you don't turn your paper. So there's that one. And actually, I'm going to extend it out even further. And then this one. So I still need it from this angle. Am I going to be able to draw a perpendicular line here from that one? So again, you only have to extend out this side. Extend this side out. So now as I run across, now it's going to hit it. I choose to do it from the other side though. Now my lines right now are not all three intersecting, are they? What do I have to do? Because I'm going to draw my altitudes in pink, so I'm going to extend them out even further. So now that I have the altitudes in, that longer, this one, that longer, I guess I can make this one longer. That one longer. And then this one, well, this is what happens when I extend it off my graph. But they're supposed to all meet. I must have this one off the smidge. I'm going to make it work. This is one of the smaller. Okay. So this one is off the smidge, which threw me off. So right here, they all meet. Obtuse, don't they all meet outside? So there's your outside. I try to do a lot of extensions on that one. Yes. What was that? We're going to apply them in some problems for your homework. So hold on to that thought until we see what we understand. You remember how we did the bench was equal distance from the tree?
Yeah, I understand that.
Well, let's go through and look at all the characteristics and how they use it. Because right now you don't see a lot of characteristics as far as length and congruent things with the angle or with the altitudes. But hold that thought and I'll answer it more later. Alright, so then let's look at the last one, only because I'm going to show on time today. I want to make sure I go through this. Alright, so here I want a right triangle. So what do you guess is going to happen on this one? Where are they going to meet? On. Now, with a right triangle, what do you know about the legs of the right triangle? Aren't they perpendicular? So, let's consider this. Look at this angle here. Isn't it perpendicular to its opposite side right there? So this leg is an altitude to the triangle. Look at this angle right here. Isn't this leg here, isn't that perpendicular to the opposite side here? So the legs are altitudes of the triangle. Either one can be an altitude of the triangle. So I don't have to draw those ones. And then from this one, so here's my angle, the right angle. I'm going to draw an altitude perpendicular to it. I drew it a little longer on purpose, and then I'm going to make these ones pink as well. And this one pink as well. Where exactly do they meet? Right here at the right angle. This is the center. I'm sorry, the orthocenter. There we go with our vocab. So this actually on the right triangle, it meets right there at the right angle on the triangle. So at the right angle on the triangle. So you can now answer 17, 18, and 19. So the altitudes meet in an acute triangle inside the, there goes my line, inside the triangle, a right triangle at the vertex of the triangle on the triangle. And then the obtuse is outside the triangle. So let's find an orthocenter. So they're going to give you some problems where you have to graph it. You've got to use graph paper. You cannot use notebook paper if you've discovered yesterday when you're trying to do something. You cannot graph on notebook paper. It's hard to get accuracy. And accuracy is important, as you saw here. When I was just a little bit off here, what happened? They didn't meet. I was just a little bit off, a smidge. So let's look at this one. DF has vertices, and then they give those two, so let's plot them. So D is 1, 2. E is 1, 6. And F is 4, 2. What kind of a triangle is this? A right triangle. So where do you think the orthocenter is going to end up? Do we really have to do anything? We already determined where the orthocenter ends up, didn't we? What angle? Which is your right angle? Angle D. So that should be the orthocenter. So angle DEF is a right triangle, so the orthocenter is at vertex D. The altitude to DF is horizontal or vertical. So here's DF. The altitude to it would be which one? DE, and is that a vertical or a horizontal line? Vertical. The altitude to DF. Right? So the altitude to DF is DE. So that's a vertical line. The altitude to DE, so here's DE, the altitude would be there, right? So wouldn't that be DF? So that altitude is horizontal. So name the coordinates of that orthocenter. They are what? Yeah, the coordinates of D are 1, 2. So most likely your problems are going to have that. So then here's where I love this part of your notes. I don't always love your notes, but I love this part of your notes. If I were you, I would create a study guide purely off of this. It puts all of yesterday's notes and today's notes together in one place. And we're also going to write some additional characteristics here to help you out. So look at your notes from yesterday. So this is your perpendicular bisectors, right? Which one of these is your perpendicular bisectors? Yeah, they really didn't show it on here, but we're going to add some markings on here. So these are all, we're going to add perpendicular bisectors here. That's what it's created by. And then we're going to add markings here, tick mark, double, double, triple, triple. Then what else did you learn that's not shown on here. We might want to add. What's on, whoops, you don't see that. What's on here that we might want to show on here that's not part of it? Well, the dotted lines. And what are important about those dotted lines? Those are the distances that the circumcenter is from the vertices, and we know that those are equal. So I'm going to put, I guess, 4 tick marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we want to note a couple of things. So the characteristics we're going to put over here. They perpendicular bisector. Each one of these has 2 characteristics. Just the name perpendicular bisector has 2 things to it. So it must be perpendicular to a side, and it must bisect the side. So those are the 2 characteristics of the perpendicular bisector. It's the only one that does not have to come from a vertex. The other thing that occurs is that the distances, well, not only do you have these congruent pieces here, you should obviously be able to tell from that characteristic. But the other thing that occurs is the distance from the vertices to the circumcenter are congruent. You want to study that because that's an important part that was created there. It's not the distance to the sides, that's another one. It's the distance from the vertex to that circumcenter. And the fact that the name of that point of concurrency is circumcenter. You want to know that as well. So those you want to study. Then turn your paper, your notes over from yesterday, and we had our angle bisectors. So which one of these 3 creates that angle bisector? Nope, not the center, that was today. This is the only one here that's showing an angle bisector, right? All right, so it comes from an angle bisector. You can kind of tell what the 2 characteristics are just by the name of the fact that it's an angle bisector. It must come from a vertex of the triangle, so that's one characteristic. And the second characteristic is that it bisects the vertex. Oh, you can't see that. So it comes from the vertex of the triangle and it bisects the vertex. Then look at this picture from yesterday. And what piece of information is not shown in this picture, but is true about the angle bisectors? Right, so we don't have the distance that these are from the sides. We don't have the distance that the incenter is from the sides of the triangle. But if I created a perpendicular line to that, it looks like this one's actually a perpendicular line. And then this one is going to be here. This one so if I created those here, don't we know that each of these are all equal? So the distance, the incenter is from each side is congruent. And don't forget that you were taught that you could inscribe a circle in here as well, using those distances as radii of that circle. And then on top of that, you need to know that that point of concurrency is being centered. It's a lot of stuff to study, but you got a couple of days to do so. So spend some time doing so. All right, so that's everything from yesterday. In addition to the fact, of course, you've got congruent angles, but you can get that from this here. Then we've got what we had today. So we have our orthocenter. It comes from what? What creates the orthocenter? Medians or altitudes? Altitudes. So this is created by an altitude. So the characteristics of the altitude would be that it must come from a vertex, and it must be perpendicular to the opposite side of that vertex. I guess the one thing that you could note on here is that altitudes can be inside, on, or outside the triangle. That is something that's a little bit different than the other three. This happens to be a picture showing them all inside. And then of course you want to know that that point of concurrency is called the orthocenter. Because the minute they tell you that it's an orthocenter, you know you have altitudes. If you know you have altitudes, you know you have perpendicular lines from the vertex to the opposite side. So that's why it's important to know what each of those are called. Because if you're thinking, what does it matter what they're called? Well, the minute they call it something, you have all of these characteristics that you know about. All right, the last one is the centroid. What is it created by? Medians. And so remember that this piece here is 2/3 of the entire distance. So I'm not sure how I'm going to say that on this one. I think I'm going to add some letters. So I'm going to add this as A, this as B, and this as C. So I'm going to put in here, just to jog your memory, that AC is equal to what? 2/3 of what? Of AB. And that's on each one. And so the characteristics of a median would be what? We all have two characteristics. What's one? Median must come from a vertex. So it comes from the vertex. And what does it do? It hits the opposite side to the point. So here's what I would do. Oh, and you also have to know that's called the centroid. Here's what I would do. I would put these on flashcards or however you want to do it. You can even do each of these characteristics as separate cards and do matching what goes with what question. It's important that you know all of these and how they interact with each other. If you don't know these, you're going to suffer. If you don't know them, you can't make conclusions about how to set things up. And then we're not going to do the lesson check for today. So any questions on that? What? Woohoo! All right, so let's answer some homework questions.